Okay, proving rectangles. Okay, we looked at parallelograms. Now, how to prove it's a parallelogram. Now we're going to look at this question, how to prove that LMNP is a rectangle. They said it's a parallelogram, okay? In the question it says that LMNP is a parallelogram. And now they want you to prove that this is a rectangle, okay? All they gave you is that MTN is 120, that means this angle here is 120, that's what they gave you. And they told you that LT is equal to LM. That's the only information you have. This thing is a parallelogram. At this stage, it's a parallelogram. And LM is equal to LT. You must ask yourself, why did they say that? How am I going to use that? Whatever they say in Euclidean geometry, you must try to use it. There's a reason they say. Okay? They don't just say stuff because they want to say a lot of things. They say things that you're going to need to use. So how am I going to use the fact that this side is equal to this side, and this is a parallelogram, and this angle here is 120? How am I going to use that? So you can put it in, that is 120. How am I going to use that to prove that this is a rectangle? So what is the difference between a parallelogram and a rectangle? The rectangle has a 90-degree angle at the corner. It looks just like a parallelogram except for the fact that it's got a 90-degree angle at the corner. All the angles are 90 degrees. So all you need to prove is that one of the corner angles is 90 degrees. If you can prove, okay, that this angle here is 90, then you can say it's got to be a rectangle. Okay, so you must prove that. Okay, so now you can say, okay, well, wait a minute, how can I do that? Let's start by saying we got the 120 here. So if this angle is 120, then this part here must be 60, because it's a straight line. So the first thing we can say is that this angle here, T2 is equal to 60 degrees. Okay, straight line. You agree? We can say that. Without any doubt, we can say that this is a straight line. So if this is 120, then this must be 60. Okay? Then we can say, but they told me that this side is equal to this side. Which means if this angle is 60, then this one must also be 60. Okay? Okay? Angles subtended by equal lines. Equal sides subtend equal angles. Okay? So we can say that equal, let's just make it, yeah, equal sides subtend equal angles. Equal angles. Okay? Equal sides subtend equal angles. So we can say that M1 is also equal to 60 degrees. Okay? So we're halfway there. Now we just need to try to show that this part is 30. That's 60. We showed it. Now we need to show that M2 is 30. If we can show this is 30, then we can say yes. Okay, so it's 90, so it's a rectangle. So now you can say, okay, well, we know this part is 120. How can we now show, because obviously if this is 30 and this is 30, then 30 plus 30 gives you 60, and then 60 plus 130 is 180. So actually all we need to show is that M2 is equal to N2. Because if they are equal, then we can say, great, they are equal, which means it's got to be 30 and 30. Okay? So the problem is, how can we show that those two angles are equal? Well, we can start by saying that this line TN is equal to LT. We can first say that LT is equal to TN, okay, because the diagonals of parallelogram, the diagonals of parallelogram bisect. So we can definitely say that LT is equal to TN. That's a fact. Okay? Because they told you LMNP is a parallelogram. So the diagonals bisect. But then, the other important thing is now, how can I show that this line is equal to that line? We know those two are equal. But how can I show that this one is also equal to that one? And that's where you need to remember what we know about an equilateral triangle. Okay, for an equilateral triangle, all sides are equal. Can we say that LTM is an equilateral triangle? We can, because if it's 60 and 60, then L2 must also be 60. Okay, 60 plus 60 plus 60 is 180. So we can first say LT is equal to TN, but then we can say, but L2 is equal to 60. Okay, reason, some angles triangle. Some angles of a triangle, so they add up to 180. So L2 is 60, therefore LMT is equilateral triangle, is an equilateral triangle. This one here, LMT. Let's just put the triangle in the beginning. Triangle, LMT is an equilateral triangle. Therefore, MT is equal to LT, okay, which is equal to LM. So those three sides must be equal, okay, because it's equilateral. And now we can say therefore M2 is equal to N2. So then you can say therefore M2 is equal to N2. They're both equal to 30. And your reason, some angles triangle. Okay, so now we can say it's 30 and 30 because it's the sum of the angles of a triangle. And you can say sum of angles of isosceles actually. Some angles isosceles triangle. Okay, because we showed now that it's isosceles. Because we said MT is equal to LT is equal to LM. And then you can say that's equal to TN. You can simply put that in also. They're all equal to each other now. Okay. And therefore it's 30 and 30. And then we can say, because we showed it's 30, we can say therefore LMNP is a rectangle. Now reason, corner angle equal to 90 degrees. Okay, remember that's the statement for a rectangle. Corner angles are equal to 90 degrees. So it's a rectangle. Okay, because we showed it's equal to 90. Okay.